Okay, hello Mona and the respected assessors and CCFO and everyone. Thanks for attending this session. This is the assessment for Mona to present her work so far, the research study. Mona, you have now time to do your presentation. Please be mindful of time and try to finish it on time. And after
Yeah.
the session, after your presentation, you will be asked some questions by the assessors and myself.
Yeah.
Thank you.
So good afternoon, everyone. So I'll just quickly start my presentation. So my name is Mona, and this presentation I will discuss my thesis on the structural performance of inclined hold-down bolts for dome shutter systems. And this research focuses on how these lightweight structures respond to wind loading and how different anchorage system can improve this stability. And the study specifically compares the behavior under different wind regions based on Australia. And I just go to the research aim. So basically the aim of this research is to investigate the effects of wind loading on dome shelter system and their supporting foundations. This includes understanding how structural forces change between moderate and extreme, which is like a cyclonic wind, as I put it as a comparing wind region B and D. And the other objective is to evaluate whether inclined anchor system can provide better performance compared to the traditional vertical hold-down bolts by reducing the structural demand and improving that overall stability of the structure. To give you like basic understanding of dome shelters is the lightweight and it's like a modular system that are widely used in mining sites, and it's like easy to transport and use in the remote area, and is often like mounted on the sea containers, which adds like flexibility, but also introduce that structural challenges as well because of they like low weights, like low self weights of these structures. Dome shelters are particularly not good to uplift forces, which caused by like the wind loads, and making anchorage design critical components of the performance. So according to the AS 1170.2, wind loads in Australia are classified into different regions. As I mentioned previously, Region B represents the area with a moderate wind condition, and the wind Region D is like a cyclonic one. And the wind pressure in Region D is like significantly higher, resulting in much like larger uplift forces and overturning moments. And these are increased the forces like placed together to have like a greater demand on both the structural system and the foundation design. We like subject to a strong wind condition, especially like in cyclonic regions. Dome shelters experiences the high uplift force that tend to lift the structures and having the large overturning moments that can destabilize the structure and base shear as well, which all of these forces affect the foundation. These combined effects increase the demand on anchorage system and often lead to heavier and more costly foundation design solution. Therefore, there is a need to develop a more efficient anchorage system that can safely resist the forces that I introduced that earlier. As like I put out some references here, and which is like studies in like geotechnical have done, and show that the inclined anchors significantly improve the performance of the structure. And researchers have which have done in like inclined anchors have both vertical and horizontal resistance within the soil, leading to increase the load capacity and better load distribution. But what my point is, these studies have mainly focused on like offshore structures or conventional foundation as their applications to dome shelter systems in like mining sites have not been explored yet. And despite like as I mentioned, the existing research on anchorage system, there are like limited information on the structural behavior of dome shelters, particularly those mounted containers one. And the other point is very few studies consider extreme wind conditions, such as like in cyclonic areas, which is region D. And there is also a lack this specific application of integrated analysis that combines both structural and geotechnical aspects of inclined anchors in the specific area I mentioned. And it's like a clear gap in the literature. The objective of this study are to analyze the force acting on the dome shelter system under both regime B and D wind condition, to compare the resulting structural responses and to evaluate the impact on foundation design. The study also aims to assess the efficiency of the inclined anchors and compare their performance with traditional vertical anchorage system. And in the methodology, it begins with calculating the wind loads using the Australian standards, as I mentioned, 1170.2 for both wind region. And the structural models of those dome shelter system are then developed and analyzing to determine the key forces such as uplift, the base shear, and the overturning moments. And these are used to design and evaluate like different foundation and anchorage configuration, followed by a detailed comparison of their performance. As you can see, I compared these in the below pictures as well, which is showing them. I'm not sure if you can see the notes here, but it's like a vertical anchor system, which is like a traditional way of using the tie down bolts for those dome shelters. And this is like the proposed design to increase the efficiency and decrease the amount of concrete we will need. And in this study, I will compare the two identical structure models which created to ensure consistent basic of comparison. And the only variable between the model is the wind loading condition, with one model subject to wind region B and the other subject to wind region D. And this approach allows to the direct effect of wind intensity on the structural behavior to be closely observed and analyzed. And wind load calculations are carried out in accordance with AS 1170.2. Then the analysis focuses on determining the key forces that influence design, including uplift force that act to the structure, with result in lifting the structure, and the base shear force that act horizontally at the base of the support, and the overturning that tends to rotate the structure. So these forces are from the foundation for evaluating a structural and foundation performance. For the foundation analysis, we'll examine how the calculated forces are transferred to the ground. And this includes evaluating the base reactions, which represent the force at the foundation level, and analyzing the distribution of bearing pressure of the soil, and determining the required footing sizes, and assessing the anchorage force. And this analysis helps identifying how foundation design be optimized under different wind locations as well. The study introduced a novel inclined anchorage system where anchors are installed at an angle closely 15 to 30 degrees and oriented toward the edge of the footing. And this configuration is expected to improve the load transfer efficiency by allowing the anchorage to resist the force in multiple directions. And unlike the traditional use of the anchorage, which is like tend to like vertically go into the soil and the footing, and resist just like a vertical loads. And the advantage of this system is that it reduces the tensile forces in the anchors and increases the pull-out capacity and reduces the shear forces acting on the footing. And the other point is improves the load transfer through like a multiple directional of the soil, and resist that and enhance the distribution of forces within the soil as well. And these benefits contribute to improve the overall stability and may allow for a smaller and more cost-effective foundation designs. And at this stage of my research, the literature review and overall research framework have been completed, and work is currently ongoing in terms of wind load calculation and structural modeling, and different anchor configurations are being analyzed to assess their performance, which I will use the Idea Statica software to make that configuration. And next step is to research, including completing the structural modeling, calculating the base reaction, which I get from the space gas model, and performing the detailed comparison between the dome shelters in two different wind locations. And the performance of the inclined anchor system will then be evaluated based on these results to determine its effectiveness. And to conclude that, this research aims to improve understanding of how wind conditions affect the dome shelter structures, and to develop a more efficient anchorage system. And the findings are expected to contribute to a safer structural design and more economical foundation system, particularly in regions subject to the high wind, which is like called the cyclonic wind region. And I put out my project timeline as well. So the literature review is completed, and I will do my structural modeling in few weeks, and then figure out the configuration of the anchorage system, and we will check the results and discuss with my supervisor and write the thesis in June, and basically ready for the final submission. I put my few references here as well for your review. And thank you for your attention. and I would be happy now to answer your question and discuss any aspects of the research in more details. I was just coming out of this.
Okay, thank you, Mona, for the presentation. Thanks for completing it on time. I just yeah, that was a very good and interesting presentation and topic that you chose and you're working. So I will hand it over to Dr. Nam for your questions and yeah.
Thank you. Your presentation. Can you hear me clearly?
Yes, we can hear you.
Yeah, thank you. Yeah, I think it's a very interesting topic. The first impression from my side is very specific for the ANCORs and with the two win reason of B and like moderate and D for cyclonic one, right? And so also the way you present, I think also very clear with like very brief, just couple of sentences, not really sentences, right? Some bullet points and with some pictures or figures and some graphs. It's very interesting and it's very brief to look through your presentation. Just a couple of comments. Sorry, at the beginning, I a bit have some technical issues and cannot hear you properly. I'm not sure if I missed a bit for the literature review. Can you please go back to the literature review?
Yeah.
Yeah, good. And here you have quite like brief review for literature and is it right that in these studies you review the more recent one is in 2011 because I still cannot see it.
Yeah, it's 2011 and 2019. I just bring out like the couple from like different years, and from recent years I couldn't find anything, so that's why I just referred to the one I found it.
Yeah, I see. Yes, it is. Yeah, you already consider the newer one, but it's not available, right? Yes, it will be very great if we can find something like more recently. Yes, but in that case, yeah. And also for the software, did you use which software did you use for this analysis, please?
I'm going to use the SpaceGas software for the modeling the structure, and I'm going to use the IDEA Statica for the anchorage system, like analyzing the anchorage system.
Okay, yeah. And also regarding the findings, I see that you quickly introduce that. Yeah, I think it will be better if you can show some graph or some more graphs of figures for your progress. It will make it easier to see how you have done with this one. I know we still have some time, yeah, but if it's not ready yet, like maybe we need to accelerate a bit to get the due date for submission with your thesis, right? Yeah, I think other than that, I think you have quite good presentation. Congratulations for that. And yeah, just go ahead with your study, please.
Yeah, sure. Thank you.
Okay, thank you, Dr. Nam. Very valid points and comments. I agree, and yeah, so congratulations, Mona, again for the good work you've done so far. I just have some comments in addition to what we've discussed already, or some we have probably partially discussed. Some comments about your work, the presentation mainly is that the pictures that you provided, it's better to be labeled and referenced. So when you're presenting some academic, work, and you bring some pictures, even if you took it, so you can just put a label and mention verities or where are the if you picked it up from another source. So it's good to put the sources or where they are or where did you take it from. So that's one thing. The other comment I have for you is that the literature review is very brief. So it's good that you mentioned only just very briefly the few papers, 2 or 3 papers or articles, you name them. It's good to maybe have 1 or 2 sentences about the findings or what they have done, what are the outcomes or what they did in their research or something like that. If you could have 1 sentence at least.
Yeah, just put it as like a note, because I don't want to make that like a big PowerPoint.
Yeah, I understand that. You try to make it like very like abbreviated and very short, but yeah, it could be better if there was any picture or any graphs or any. But that's good. Not too long. Not like that. Yeah, but that's fine. Other than that, I don't have any major issue with that. So it was a good presentation. Thank you. That probably can go to the other assessor, and we should we might be hearing from the other assessor about their comments, and then we can and you can work and complete your presentations and continue the work as per the advices given to you by myself and the other assessors. Yeah, that was from my side. Any other questions you have, Mona, or any other comments, advices, or comments from your side, Dr. Nam?
I'm fine. I think after this presentation, I have to start to model my structure and then go through the software basically.
Yep, agree, and we can have a discussion on that later on.
Yep.
Yeah, all
Thank
good from
you.
my side. Thank you, Dr. Ahmad, and thank you, Mona.
Thank you.
Thank you. Thank you very
Thank
much.
you. Thank you all.
Have a good day. Cheers. Bye.
You too. Bye.